Hello everyone, and welcome to today's live stream where I have some amazing news. The camera info node is now in Blender 4.5. If you get the latest build of Blender 4.5, either from Blender's website or from downloading the build yourself, it's now available. The developers have accepted it, approved it, and I'm very grateful for them because they helped fix a couple of the dependency issues with this node and gave suggestions on what to change and update, and it's now in Blender. I am very, very happy about this. So you may be wondering, what does this node do? Well, you can kind of see a little bit of it right here. This node gives the camera projection matrix and a lot of other data, which can be used for camera culling and a lot of other cool effects. Basically, getting the data from the camera and then outputting it so that you can use it for whatever you want. So let's go and see how this works. So in this example right here, I have a little node group for camera culling, as we can see right here. Actually, it's only been 1 minute, so let's wait until a few more people get into the stream. So let's go over what's up with the node. So here's the projection matrix. That's basically, the matrix that gives you the perspective so that you can get the distance to points and stuff like that. The focal length, which is just, the focal length from the camera. The sensor, which is the sensor is how big the camera sensor is. So in this case, it would be like that. Oh, that's a dependency issue. Or actually, is it? That may have to be looked into. I will need to check that out. And that can be horizontal or vertical, but that's all just handled, which is very, very nice. And then we have the shift. So in this case, whoops, wrong thing right here. There's the sensor and then the shift. So the shift is if you shift the camera, we can see that happens. Looks like there may be a dependency issue, but I'll need to look into that. At least when it runs, it all works quite well. But we can see the shift works just fine. And then maybe it's because it's inside of a node group. I'd have to take a look at that. There's a clip start and clip end, which is basically, in this case, if you set the clip start to be something like 4, we can see that. Well, actually, no, that maybe we can see. Oh, we would have to look at the actual data for that. But yeah, if you can't tell, I've done minimal prep for this just because I've been working on other nodes, but that is for the future. We can see that the data is correct in here. The focus distance is set to 10, but that will automatically update if you set like a depth of field object. That is because I used the correct Blender kernel for that. Function for that. Then we have the is orthographic, which will let you know if the camera is orthographic or perspective. If you're asking about panoramic, that is not supported because panoramic is weird. But yeah. And then last but not least is the orthographic scale. Again, if the camera is big or small, it will handle that. Which, did I implement? Yes, I did implement that in here. So again, camera culling. I'm thinking about making a node group to make this easier for people. They can just add it and it'll work. But there's a few things I have to do before then. So what I want to do right now is to make it so that the camera culling, I'm going to basically remake this from the ground up to where it will just call the instances in post. So if you have a collection with a ton of instances, you can just apply a geonode group and it will just call them based on, the collection, which would be more practical instead of having to do it before the instance on points and, all that good stuff. So I'm going to copy you, duplicate you, and then go and do that. Let's go and hide all of the other things so that they just straight up won't calculate. So here, the goal is that we have a ton of instances just around here, and then we're going to call them in post. The colors of these do not look they don't look that good, so I am just going to pick one icosphere for the instance, turn off pick instance, and then we will delete all that, and we're going to start from scratch. Okay, so yep, that's all good, and I'm going to set a random scale, even though right now scale is not, wouldn't be included in the camera culling because, that's just, I could include it potentially, But for that, we would need the instance bounds node, which I am currently working on. That one looks like it's gonna be doing well. But yeah, that's the future. Let's not get too ahead of ourselves. I've been trying to keep myself back from going too fast, because my brain really breaks when I go way too fast. Okay, so let's get the camera information. And then in here, whoops, we'll go and get the active camera. Now the camera input could be anything we want. But in this case, we're going to choose the active camera. Some of you who've seen the previous versions of the node may be wondering why the is active camera option is removed, and that's because there is going to be another node in the future that will be able to compare data blocks. I would have to double check on that, but it was removed by the developers for a reason, because it would be a bit redundant because of other nodes. But yeah, let's go and take a look at this. So I need to, it's been a hot minute since I've actually used the node instead of actually just went and looked inside the code. But I'm going to be doing this on the points first, just so that I can visualize it easily, and then we will go and do everything else. So let's go and take a look at the point, but I'm going to transform the point position by the matrix. So if we're going to transform point, we're going to put that into there and put you into here. So if we take a look at the colors, we can see that the colors look like this. Oops. I need to remember to pin you so that we can keep seeing you. So this will adapt when the camera changes. So in this case, we can see that the projection has slightly changed. But that's not in world space. That is just the camera projection right there. So we need to get the active camera location. So here we're going to use the object info node. Now, this is one of the reasons why I want to make a node group for all of this, because it can be a little bit inconvenient to have to set this up. Oh, is this in the official branch now? Yes, you can download this right now, and it is a part of Blender. I am so excited, so happy. My goal was to get one node in Blender 4.5, and hey, I hit that goal. Again, I'm extremely grateful for the developers because they helped out a lot with all that. Let's see, if I remember this correctly, which one of these do we have to do first? Let's take a look in here and remember to set the clipping on this camera to be a little bit further. I mean, that almost looks right. I have to remember. Let's go and separate XYZ. Again, this is why I want to make it a node group, but nope, that seems to work correctly. I think we just need to divide it by the distance, and that might be the key. Let's see, let's go and divide by the z distance. Again, I need to figure out how to make a... Well, that looks close to correct, except I think it may be inverted. So, let's see. I just need to... Let's do... I'm not looking inside the node group because I'm trying to do it from scratch, but there's a good chance I should try to do that. Okay, let's go and take a look at the node group that I made previously. So let's go into group, camera call. Okay, what did I do here? Transform point, yeah, I got there. And then, yeah, we could ignore most of this, but I just have to, okay, divide that, okay, and, okay, I get it now. I just screwed up one little thing. We need to subtract 0. This is basically a multiply by -1. Actually, let's do that instead. -1, so that here we can see that... Am I pulling this from the wrong part? No, it should be from there. Wait a minute, let's look in there again. Yep, that seems to be good. Let's go and hide the unused socket parts from there. Then we're going to hide this, put this up to here, take a look at that, and then we'll go and see how this looks. Again, I'm going to check it once again. Yep, divide, absolute. Oh, the absolute, I forgot. I forgot, so we need to absolute so that we can get the proper gradients. Apologies, I should have been more prepared. But then to get the gradients from the center, you know, we're going to do the maximum here, and now we can see we have a gradient from the center. Let's go and put in quite a few more points so that we can see this a little bit better. There we go. We can see a nice gradient in the middle. Some very interesting, like, optical illusion stuff with the gradient going over the back. It is also gray. But yeah, we can see that that works right there. So with this somewhat simple, well, it's not the simplest setup, but it's not the worst. Maybe I should make a tutorial about this once it comes out. But now we have that. So if we use a greater than node, we can now cull if we want to. So if we set this to be 1, we can see that anything inside of the camera view will be set to 0, and everything outside will be set to 1. So now we can go and delete geometry. In this case, we're going to be deleting instances. So with that setup, again, need to make it a node group. All of a sudden, camera culling is now a thing, and because we have that gradient, we can go and set a little buffer area, if we so desire, which is very, very nice, very cool. All right. If I understand correctly, you made this node by Python. No, this is hard-coded in C++. You have to go and download Blender source code, build the source code, rummage around in the source code, and then, you know, make a new node inside of the C++ source code. It's an ordeal, and there's a reason why, you know, we just use nodes. Because going through all the C++ stuff is a little bit inconvenient, shall we say. Yeah. Mainly due to the dependency graph. Like, getting the data for this node wasn't difficult. And there is more information I could possibly add in the future. Like, I do potentially want to get, like, the aperture stuff in there. I was told that getting data from the DNA files is okay. It's just a matter of bloat, because if I add in everything, this node will become horrendously huge. Yeah. How would you go about culling something like cubes? Well, that I have a recipe for that I'm cooking up behind the scenes. But with instances, you know, what if you can get the bounding box and then take that into account when you are doing your camera culling? That is why I am working on a node for that. But there are a few little things I have to do before I can put that through. And unfortunately, in the week or two since I've worked on that, because I was busy with other stuff, I forgot how to do it, so I need to remember. Fields are very complicated under the hood for someone who knows nothing about them. But yes, again, camera culling, it now exists. But there are a few caveats that we need to do in case, like, the camera is orthographic. So in this case, we need to switch this to be just 1 if orthographic is true. So in this case, the orthographic camera should work perfectly fine. As we can see here, it is annoying that so much has to be, you know, it does require a bit of setup, but this is a building block node. Again, if you want all that, it works out just fine, and you can set the start and end clipping distance so that you can hide even more. So there's a lot of things that you can do. And I accidentally started rendering an Eevee. This will take a few seconds. Oh, that's fast. But yeah, now you can do anything you want. And why are they? Oh, they are like that. Okay, let's go and use a power node so that we can change the distribution of the... This is not necessary at all, but there we go. And we'll set this to be like 0.5 and 0.1. We'll set this to be like 3. I want a much better distribution from the small to large. Yeah, that's okay. There we go. So now if these were all like pebbles or something along those lines, it would work out very well. Or trees. I've had instances where I've needed to cull trees because there were so many in the scene, but unfortunately we did not have this node. So yeah, fun stuff. But now it exists. That was weird. I want to delete the animation, not Control-Z the other stuff. But yeah, so much stuff is now possible. But in this case, since we have the radius, I believe that we can... Let's see. I'll need to think about that in detail. How would I offset the... Yeah, the culling by a set distance? Now in here, it's all normalized. I need to determine... yeah, how would that work? I know it's possible. It 100% is possible. Just given the instance radius, or the instance scale, and then the instance bounding box, you would have to multiply those two once. That becomes a viable solution. But I see that as something for the future me to figure out off stream, because I think I would screw it up on stream. But it has to be, okay, now how would that work? You have the scale of it, and then you can multiply that by the oh wait, no, that might actually work. Multiply that by the distance. And then, wait a second, oh, wait. 1 second, everyone, this might actually work. If we get the instance scale, and then we get the length, again, we would need the instance bounds to actually check if it's viewable in the instance bounding box, you know. But again, that is for the future. So in this case, maybe I can offset you by the distance. We multiply you by that, and then just maybe subtract. We can see that, no, we want to add in this case, and then we're going to set that to be 1. We can see that something's happening similar to what we want, but it's not exact. And also, I think the length, no, the length should be the radius, but if we divide that by 2, math divide by 2, that should be closer. It doesn't, I'm not sure if this is correct. Because if we zoom out, zoom in, we can see that the actual buffer distance changes, but it is still keeping itself in line. So I will need to look into that, but as we can see, we are close to that solution. And since I've rotated the camera a little bit more than it should be, oh, is it rotate? Oh no, that's the shift. I forgot to undo that. There we go. Works with extra transforms like graph editor noise, also keyframed focal length. Yes, everything should work. There may be, I'm not sure if this is the latest version, but there does seem to be a little bit of update issues when it comes to dependency graph stuff. But I'm pretty sure all that will be fixed soon. Let's go and actually, I think it may be because of the active camera node. Let's just go and check real quick. Now in Blender 4.4, they added the object constant. So here, let's see if we edit this. Okay, here we can see that that works out just fine. It seems like the active camera node is a little bit iffy when it comes to the dependencies. But here we can see all that works just fine. No matter where you turn the camera, it will function correctly. Also, one last thing, you probably want to set the ID to be the index beforehand, just so that any random effects that you do in post will be accurate to the pre-culled versions. So let's go and use a instance scale, or scale instances, and then we will use a random value for this. So here we can see that, ooh, that actually looks pretty cool. Here we can see that the random value is stable because the ID is stable. But if we do this, the ID is still stable. Huh. Interesting. I did not expect that. Huh. Maybe it's because they're instances and not just points. I would need to look at that. Well, anyway, if I were to make a node group with camera culling, we can switch this from instance to points and it would work perfectly fine. And then, right, let's go and take this out temporarily. So yeah, active camera seems like there may be a dependency issue or two in there. But other than that, yeah, as we can see, the shift works just fine, the vertical works just fine, and then the, oh yeah, the f-stop is not included, but the focal distance is. So we could swap out these instances with the lower versions if they're too far away from the focal point, which is something you may eventually want. You know, LODs are very popular in games, so including that functionality in here could be very cool. Now, I have looked into potentially figuring out how to swap geometry sets or access the geometry set ID, but that there's a lot. Well, that's again for another time. Again, don't get ahead of yourself. But yeah, that is that. So let's try this on a mesh instead of a piece of geometry with instances. So let's go and subdivide this plane, or actually wait, no, let's just keep what we have here, hide the plane, and we're just going to have a grid. So let's go and get a grid, put this over to here, and then we're just going to delete geometry on the instance, or on the points instead of the instances. And since the math is the same, as we can see, if we make the grid a lot bigger, and then give it like 250 points, we can see that that works out just as well. So if you had something like adaptive subdivision, you can now do that with geonodes. But do keep in mind that since this is on the CPU, adaptive subdivision would be rather expensive, but maybe less expensive than what the alternative would be. All right. Let's actually try, yeah, let's just try that out for a little bit. Just checking a few things with all that. That seems to be good. Again, if you want to turn up the kind of buffer distance, you can. Let's see. Oh, let me read the chat. Sorry, everyone. I've been neglecting that, except for a few. Okay. Does this change how to approach Raymarched Fractal / anything Raymarched as actual geo? Yes, it would, because you can automatically, well, actually, with other Raymarch techniques, you would parent a plane to the camera. Well, it would make it more robust, because you can put a plane on top of the camera and it will automatically adapt to the camera frustrum, I believe it's called. Basically, you can put a plane here and it will always be in the camera view, even if you shift it and all that, which is good for assets. You can just plop it in and it'll just work no matter what camera you have, even if it's orthographic, if you implement that. Let's see. I love the new volume nodes, and the camera info node seems helpful for large scene optimization. I wish 4.5 was stable already. As far as I know, 4.5 hasn't crashed for me, but again, with these alpha builds, you know, it can be a little bit iffy at times. But 4.5 is going to be a long-term support release, so that will be very, very good. That will be very nice. Yeah. Let's see. Official branch. Yep, official branch. Can you add panels to the output to avoid bloat? I have considered that. I've mentioned that to some of the devs. And while I'm not entirely sure, like, not many built-in nodes have panels. Maybe this one might be an exception where I'm not sure. Just because there is a lot of information that you can get from the camera, and stuff can always be added with a patch. Stuff being removed is a lot more difficult. Just because of, you know, if people use it. Alright. I made an adaptive subdivision node group, but this will definitely condense it. Ah, nice. Nice. It'd be interesting to check if points/objects in screen space are smaller than a pixel and do stuff with that. That should be possible. Well, okay, this leads into another thing. The resolution X and Y have been removed from the camera info node because that's technically scene data. It is used under the hood for the projection matrix, but yeah, there may potentially, if I get around to fixing the dependencies and stuff like that, potentially in the future, now this is a big what if, there may be a scene info node, which will have stuff like the resolution XY, the gravity, the start and end frames, and stuff like that. So potentially, that may be a viable thing in the future. Worst case scenario, you could use drivers, but, you know, drivers are when it comes to, you know, super stable stuff. But yeah, even though, you know, if they're context dependent, they should be fine. Again, worst case scenario. Let's see. What were we doing? Oh, right. Adaptive subdivision. So let's, should I do that right now? Because that may be, if I take the face center, oh yeah, no, that should be doable. So do I make this into a node group right now? I think we can. Well, I already have this node group, but, And this one's very nice because you just put in the input camera. Oh, also, another very cool thing that the devs added, I believe, the day before yesterday. Now, if you have an input and hide the label in nodes, it will show the label right here. So in this case, instead of showing object right here, it's showing camera, which is the label under the hood. I need to check if that happens... Hide value, was it? No, oh, there isn't a hide label in there. I'll need to double check on that. But yeah. Actually, if you were to go and just eliminate that, I think that would be... okay, that would happen. Okay. Again, last night I was working on some other stuff, and unfortunately, I did not prepare for this live stream as much as I should have. Actually, no, this will just be camera. There we go. But yeah, that is some cool stuff. Okay, so this should work on every single domain. This is why I like these kinds of nodes. They're stable, even when you change domains and stuff like that, because they're just, you know, math. Let's go and set this to be let's do 50. Let's see, and then in here we will use a separate geometry node on the face domain. So if it is inside a certain area, in this case I'll make it 0.5, it'll separate these, and then the inverted we will subdivide and then join afterwards. So in this case we will join this, put it in there, chop out everything else. So we should see, if I did this correctly, position... working. Actually, let's double check. No, it is not. Okay, what is going wrong? All that seems to be fine. I don't see what the issue would be. Unless I severely screwed something up. Let's go and check this stuff on the domain. So this is on the face domain. Why would that only be... Oh, no, wait, we need the gradient, yeah. Why is that so huge? I must have messed something up under the hood in here. What could I have messed up? Besides, let's set that to be a negative. Whoops. Let's set that to be a -1. And also, you need to technically set maximum so that the projection and behind the camera will be correct. That's okay. Yeah, what is, the issue here? Because if we set it to points, how does that look? Again, oh yeah, no, this got screwed up. Oh no. Whoa. Oh, was I just using the wrong camera here? Okay, that's weird. So it does work, it's just a little bit funky. Okay, yep. As we can see, the subdivision is functioning. Let's go and just showcase this a little bit more. So you could just repeat this with the kind of focal part getting smaller and smaller the closer it gets to the camera. Though then again, in this case, it probably would be best if it were just the distance from the camera, and then anything outside of the view range would be just normal. So yeah, those are the options. Hello to everyone in chat. Let's see. This could be used for stuff to... oh, this could be used to convert stuff to clip space, which is how you compute dicing scale for adaptive subdivision as far as I know. Yes. Like in this case, since I invert the position matrix transform, so again, transform, just think the simple way of viewing it is a location, a rotation, and a scale. Running out of breath, sorry everyone. As long as you ignore like shearing and stuff like that. So like with cameras and all that, this should be fine. And then in here, we can separate the Z, which is in camera local space. And then you can use this for clipping. So you can take this and say, hey, if the distance from the camera is less than the clip start or greater than the clip end, call that as well, which would be an option in the node group I would make. Actually, I could do that right now. So if something is outside of that range, it will just eliminate itself. Yep. And here, the distance would be like that, but yeah. So in this case, this will make this a lot bigger, which I'm not the happiest about. So let's go, yeah. That's why we need these node groups. Again, if you're wondering, wait, why not just make all work under the hood? It's because just bloat. It's better to have the building blocks and then make node groups on top of those. Though unfortunately, I do not know how to implement node groups into Blender. Because I would like to put panels in some of those and stuff like that. But yeah. If we use an AND node, or wait, this needs to be an OR node. In this case, if it's outside of the clipping distance or outside of there, it will give us a thing. So in this case, we can see that the clipping distance is working as intended. If we go and change this and set this to be less. Oh wait, nope. That is not functioning as intended. We can see the stuff in back of there. Oh no, sorry everyone, I screwed some stuff up. Maybe that needs to be a bit more? Why? It is odd. Why would that be? It's greater than the clip start. Yeah, and if it's less than the clip end. Oh, this should be an OR. Okay. There we go. In this case, everything turns out to be white. Okay. Oh wait, no, that's... Sorry, everyone. There we go. In this case, and then that will need to be an AND. Oh, and the distance needs to be negative. Oh my god. So many things to consider, which is why I want to make this a node group instead of that. So here we can see we have that part or that part. And then I need to swap these yet again and then make this an AND. There we go. Okay, so now with all that done, we can see that the clipping is half working. I'm somewhat confused. Oh, that's because this is reversed? Nope, I have this the wrong way around again. This needs to be an AND, and that will be an AND. Okay. Simple bitwise math. Or Boolean math, yeah. There we go. Now we can see that that part works just as well as it should. Now, could we incorporate that into the gradient? Yes, we could. But it would have to be a different dimension. This would be like the normalized depth gradient. Which actually, yeah, let's go and do that. So we take the depth, which is multiplied by -1, because cameras are a bit weird when it comes to where it's pointing. Then we just do that, and then we output that. So instead of doing all of that, we can use a compare node, or no, an equal to node. See what's inside and what's outside. So in this case, it would be 0.5. Whoops. 0.5 and 0.5. So now with that normalized result, that simplifies a lot. In theory, In theory. Right, we get the distance, we do the clip start and the clip end. That gives us a normalized gradient. Let's go and test that. Sorry that there's so much testing going on. And we need to invert that result because I want it to be like that. Clip start. Oh, okay. Yep. Okay. I will read the chat in a second, everyone. My apologies. But here we can see that the normalized gradient is working as intended. And then, oh, right, we need to make this like 0.999 or 0.4999. That will be in. Oh yeah, let's go and just turn off the clamp on that. So it could be like that and work just fine. There we go. So now if we check what's inside and what's outside, it's working as intended. There we go. We get the depth and the normalized depth. And the depth is not reversed. So that should be, yeah. And here I can just put you right there. Again, it is getting messy, and I'm not the happiest with that, but it is what it is. Actually, should I eliminate the inside part right here and then just have... be normalized depth, or no, clip depth. No, and I spelled it wrong. Go. So yeah, those are options, and there will be more options in the future with the node group. Again, I will put this up on Gumroad if it doesn't become part of, if I can't implement a node group and all that fun stuff. Yeah, there is that, so we can see the clip distance, which goes to 1, and then you just can't see it straight up. Yeah. So if you wanted to do camera culling with the clip depth, you can. All right. So I guess you could put this into the recursive or the adaptive subdivision. So you just repeat this every time, and every iteration you go down by a level. Should I do this with a repeat zone? That sounds like a recipe for disaster, but let's try it. So repeat zone, we'll do this, we'll put it into here, and then we will separate, subdivide, and recombine. If you want to do this properly, you would have you would have pre-separated cells so that you don't need it would be easier on the separate geometry and all that fun stuff. But, it is what it is. So here we will do a divide by 1. So 1 divided by 1 would be 0. Then 1 divided by 2, yep. Or actually, wait. I think that'll work, but I may need to flip the, so here, level 1, level, oh. Well, we can see it is working. I may just need to add 1 to the level. And let's use the depth, actually. And then flip this around. Wait, am I doing something wrong here? Or I could just use an index switch and be extremely lazy. Okay, let's go with that one because my brain cells are rather just a little bit fried at the moment. Okay, so the depth, if it's greater than, we'll do 0.5 and then 0.25. So we'll have the iterations, and then we should see. No, we want the gradient, not the depth. Okay, there we go. Okay, so if you want to do it in a very simple manner, without having to, you can customize each of the levels, which I think, is pretty good for better usability and all that fun stuff. Let's go and add another item. So here we can do 7.5, 0.5, 0.25. Then we can go up another level, and then boom, there you go. Adaptive subdivision based on this part, but if we use the clip depth instead, we can see that it is affecting a lot more. And then beyond here, we would go and nullify everything beyond that point. which is a good idea. So let's do an and node. So needs to be that and, wait, whatever gets separated subdivides. Okay. So we need to do an equal right here, an actual equal, and set both of these to be 0.5. So it will only subdivide if it's inside of the view plane. Uh-oh. I screwed something up once again. Let's see, what did I do? Let's go and lower the subdivision count. So if it's that and that, if it's greater than that, let's go and check the data right here. And that, then it subdivides, or if it's inside the view plane. So both of these equal that. Oh, shoot. The selection was the wrong way around. I want it so that for some reason I chose to use the inverted one, but that's a very, very dumb idea. I want everything closer to be, yep, there we go, okay. A little trial and error happens to the best of us. As we can see here, that happens. And then anything outside of the view plane, we also want to not be subdivided. So we'll use the gradients, then say if it is less than, it will also do the thing. So here we go, and now, finally, we can see that the adaptive subdivision is working as intended. There we go, there we go. Took a lot more setup than I would have liked, but what can you do? Then with the depth, it is normalized. So you just adjust these as you wish. Then if there was another level, you can go and do that. So if you, for example, had a material on this object, and since this is an actual build, I can go and actually use Eevee to render all, well, actually no, I can render it in the custom builds, but yeah. Let's go and use a noise texture to offset the geometry. So here we can actually see what we've done. So here we'll put you into, whoops, wrong thing. Let's go and move you just up and out of the way. We'll put you into displacement, set this to be 1, and then we'll do displacement and bump. So here, we can, actually, what is going on there? Huh. Is that because of the clipping distance? I do not know. But here, if you had, say, adaptive subdivision and all that, you know, there will still be issues with the seams and all that fun stuff. Wait. Oh, is this... I need to set this to be the position. Ah, okay. So here we can see the subdivided parts. Let's go and turn this down by quite a bit. Why is it looking so incredibly... There we go. So here... Wait, something's up with the color management. Oh, it's set to... Ah, no, that makes sense. Okay. Let's set this to be... Let's use the sun instead. Let's do that and turn this on with the scene lights so that we can get some shadows. There we go, okay. So if you want to do adaptive subdivision, and yeah, if you want all these seams to be correct, wait, why is the clipping distance acting a bit weird, or is that just Eevee? Weird. We can see that there are some errors just because you go up and down the subdivision levels rather quickly. I think when Google Earth does this, they have some geometry just extruded downwards, so that the seams aren't as visible. But we can see here that the... Actually, let's do... Oh wait, we can't do displacement only. Unfortunately. Yeah. I really wish we could just do displacement on the GPU, because that would be better. But, actually, let's do that in geometry nodes instead. My voice is getting ever so slightly tired. I apologize, everyone. Once again. Let's go and use a vector math multiply. Nope, vector math multiply. And put it into there, set it to be 1. So here we can see it even when it's not rendered, as it should be. So here, once again, I don't know why that's acting weird. It's like the normals are inverted. Is the camera scale inverted? Hold on. No, all that's fine. Empty's fine. Yeah. I don't know why that's happening. Maybe just an overlay next thing. But even with sharp shading, or flat shading, we can see that the adaptive subdivision is working. And then when it goes to here, it really clamps to a very, very harsh cutoff. That is what we intended. All right. Very, very nice. And let's go and shade smooth. Set shade smooth. All right. That's good. That's very, very good. The hard part about adaptive subdivision, sorry, is making the connecting triangles between sub-D levels so that displacement works correctly. Yes, yep. Again, if these were, how would I make this work properly? Like maybe a triangle grid would be better, but square grids are the easiest to deal with. Again, from my adventures inside of Google Earth, which uses this quite often to stream in different levels of detail. They just have it so that the higher level of detail versions render in front of the lower of detail versions, and they extrude the sides downward by a bit, just so that, you know, it's fairly invisible, the seams. Okay, we're at 46 minutes, so I think we should be wrapping up the stream somewhat soon. But again, just a little look into the future, which is very, very exciting. What is going on with you? Is it the clipping distance that's screwing everything up? Let's go and fix that. No, it's not that. Huh, I don't know what's up with the shading here. Well, what's up with the other camera? No, that one's fine. So it's something with this that is having a difficult time. And it can see the sphere even though it... Wait, it's viewing the opposite side of the mesh. How is it doing that? I'm going to assume that's an overlay issue and not a geometry nodes issue. Because it should not be able to see the sphere or the empty right there. But if we look down here, we can see that. That is really interesting. Trying to merge these seams would be a nightmare, most likely. But in this case, if I extrude the non-individual sides and then... Oh, I forget how to do this correctly. We need to set the position of the seam part, not the top. So if we set this to be not that, go and check this. We need to evaluate this on the point domain. Oh yeah, I think this is how it's done. In this case, we move this part downwards. Yep, that's it. And then we set the offset scale to be 0. Here, should see, no. If I actually connected the right parts, we should see that that's like that. Okay. Now, if we go and delete you and put you here, we now have horrible smooth shading, but that can be compensated for. But here, actually, is the set normal node in? Oh no, the set normal node is not in 4.5 yet. Oh. Huh. That's weird. And here we can see that, I don't know what's up with the camera right there. Something's up. Maybe because the camera was made in a custom build? I don't know. But if you could fix the shading so that this actually uses the normals it's supposed to, at least at the seams, they would be closer, you know, less visible. Yeah, that is that. So I'm just going to move all of you up and out of the way so that we can focus on the regular stuff. That is, whoa, that is weird. What did I, oh wait, I think I know. Clip start and clip it. Yeah, there we go. I did not though, huh, I didn't know that would happen. Oh, that is funny. I did not know that could happen. I don't want to use that now. Okay, that was the issue. Alright, which means that this setup was screwed up from the get-go. Yep, it was. It very, very much was. So here, these parts need to be flipped again. There we go. Okay, so that was a problem with that, okay. The issue was that the start and end were inverted, and I accidentally did that, which was very dumb, but it's fixed now. It is fixed now. Let's go and flip some of these parts around. Oh, that might have been a mistake. You right in there. There we go. Again, polygons are very, very precious, so we need to use them very sparingly. Right, that seems to be most of it for today. Let me go and just clean up the node tree by a little bit. So yeah, so many things will be possible in the future. Again, just automating everything. Getting the projection matrix would be a huge pain to do with drivers. And drivers, again, their stability can be a little questionable at times. But yeah, now just having that data is great. Very happy about that. Okay, anything else I need to go over? Again, this could be a node group, so let's go and make it a node group. So in this case, ID just gets set, which could be input, and then this could be like a call, let's see, call factor. I'll just name this, yeah, call factor. And then you can switch the nodes, the modes between instance. So if we had an index, or actually a menu switch. Menu switch. Menu, come on. Sorry, I'm feeling just a little bit tired at the moment. We can switch this to be from instance to points to faces to whatever we want, even curves, everything. Please make a GeoNode lesson. Yeah, I have some stuff on my YouTube channel that would apply in that case. So I would recommend looking at my old stuff, even though that's probably like 3 years old right now. I've been doing all this for way too long, but it's been good. Okay, let's make the input camera. So let's be camera. And then, yep, that's all fine. This will be instances. There we go. So this will be instance camera. Or it would be camera calling, and then you would just switch between instances, points, and all that stuff. Then you can change the factor. And then you would have another checkbox for the clipping distance, which is probably good as well. Change that so that it is definitely on the instance domain, so that that weird stuff doesn't happen. But yeah, the goal is to have a convenient node that you can just place in and call your instances, so that it won't lag your machine. Because instances are just fancy points. Points pointing to other geometry set data. Okay. Oh, you got the loop node over repeat. Yep. I also heard that the compositor got a bunch of nodes like vector math. Yes, it did. Let me go and save this in its current state. Oh, what happened there? Right, we need to connect that. I love the input fading. Let's go and save this at the moment and take a look at the compositor. Because the compositor, if it's in this build, got the noise textures and vector math, which people have been wanting for a long time. I think the main hiccup with that was that sharing nodes between the compositor and shader nodes and geometry nodes was a bit of a pain, but now they are supported. So if I wanted to just use the, oh, and there is also the image info node, which you could put in an image, in this case the compositor image, get the pixel coordinates. So it's almost a little bit like the camera info node, except, you know, few levels up where you can just get the coordinates by itself. But if we use, let's go and split the view right here and take a look at the 3D viewport. Right there. Actually, should we just render a frame? Or no, let's view this in real time. Even though there were a few issues with that in the past. Set this to be always. So here we can see we're just getting the texture coordinates. And then we can get the pixel coordinates, which this should be a lot brighter because, you know, all the pixels can go from like 0 to 1920. The resolution is a constant input, I believe. Here we can see that will just be 1920 by 1080. The location. Oh, that's if you move that, and then you get the rotation and the scale. So yeah, lots of cool stuff. We can use the texture coordinates to put in a noise texture. So now film grain is easier than ever to implement. But yeah, I forgot who put this in. Uh-oh. Compositor is glitching out again. Yep, it's having a wonderful time. The Compositor seems to be a little bit broken. What was that? Interesting. Okay. So here we should be able to see all this. Is the GPU compositor on? Because, actually, wait. Option... it's using the CPU, that's why. So if we use the GPU, it should be significantly faster. I don't know why it's acting a little bit odd in that case. Not quite as fast as some people would hope. Let's turn off normalize. I don't know what's wrong with it, but it seems to be a little bit broken at the moment. Huh. The compositor seems to be a little bit funky at this time. The texture coordinate seems to be broken as well. Pixel core. Oh, okay. Something's a bit off right here. And wait, now it's working? Did it just need to like refresh or something like that? Yeah, that, again, this is an alpha build with all that. But anyway, let's go back to what we know. Let's go over here, disable the compositor there and in here. Let's go over to, not shading. Let's go over to geometry nodes. There we are. Okay, so let's go and wrap up the stream. So yeah, camera culling is now a viable workflow in geometry nodes, which I'm very happy about. Again, thank you so much to the devs. I am so grateful for their help and advice when it came to implementing this node. And yeah, let me read the rest of the chat. Let's see, I don't mean culling, I mean converting geometry to be in clip space instead of global space. You can then use that geo in clip space. Okay. I would need to look into that. Let's see. The hard part about, oh, I already read that. You should do some poke faces, triangulation instead of subdivision. That may be a good idea. Let's see, I found a couple of good methods that worked to add good seams. Somehow the iterative approach I found was the fastest. Okay. I had no clue you went live. Happened to catch you streaming. I just wanted to come here and say your stuff is incredible, and I sincerely appreciate how open you are with your process. Yes, I always want to show my process because, you know, getting here, in some cases it was a bit difficult learning some of the techniques. Again, I don't come from a great math background, so I want to show my process so that other people can see how I got to there, and if they can hopefully do better than me in the future. Let's see. What if instance radius was included so it doesn't exclude particles on the edges or include too many? Yes, we did try that earlier. It is somewhat... The instance scale could be included, but that is more of a band-aid with the main issue, which is that some instances can have very big geometry sets, but you would have to access the bounding box information for that. which is why I plan on working on an instance bounds node to efficiently get the instance bounds from each geometry set rather than the current workaround, which means that you won't have to evaluate the bounding box on every single instance, join those together, get the data, and then separate them again. It was a huge pain. But that would allow for more accurate camera culling, which is very good. But yeah, hopefully I can get that one up and running, and then, who knows, maybe I can get the scene info node working with the dependency graph, which I'm not entirely sure about that. The dependency graph is difficult to deal with. I saw the dependency graph, like an actual graph of it, and it was extremely complicated. I need to study that in detail, but yep. Let's see. Glad to hear it. Struggling with math, so I can understand that. The results you get are crazy, though. You're super skilled with it, and it's cool to see. Yep. Geometry nodes is extremely powerful, and I'm looking to make it even more powerful with just a little bit more communication between different objects and geonodes. Again, I have quite a few plans, some of which may make it into Blender, like again, the camera info node actually made it. I'm so happy. This is currently in Blender 4.5. The current build you can download on Blender's website. You don't have to build it yourself. It's currently available, so hey, you can go and get it right now. But I have a few more plans in the future. Again, the big thing that I'm hoping to, the biggest, I guess, shift, like, in communication between geometry nodes and other parts would be the sample attribute constraints. But I'm not sure if that one is in line with Blender. It is very interesting in that regard, because adding a new constraint, I'm not sure when the latest constraint was added, but it is, constraints are old. They're all inside one file, and that is very daunting to get into. But yeah, again, just these nodes, the nodes I'm making, are just better communication between geometry nodes and the rest of Blender. I saw someone mention that they wanted just kind of like a general attribute node to get data from anywhere. Unfortunately, I can't implement that just because of major dependency issues, because the data could come from the scene, it could come from a specific object, it could come from like the view layer, it could come from anywhere. I can't implement that, so I'm doing what I can and just getting data from the camera, which is very nice. But there are big plans when it comes to data fetching and then exporting data from geometry nodes, but that is all in the future, which I'm very excited for that. So yeah, I guess that will be all for today. We are at 1 hour. Thank you all for watching. I hope you all enjoyed, and go play around with the build. If you find bugs, report them, show me what you've made with it, and yeah, have a good one. Again, this is the current setup for camera culling. I know it's a little bit complicated. I'll probably put this up on Gumroad in the near future. But yeah, yep, that is that. Thank you all for watching, and I will see you next time. Have a good day.